Welcome back to another one of my applications of differentiation videos. This will be focused on the Rolle's theorem, and this is the third episode. We'll be focusing on finding two c-values. Okay, so for us to use the Rolle's theorem, first the function has to be continuous on the closed interval from a to b. So that means between the 2 points, it has to be smooth and it has to all connect. There's no changes or points or anything. And the function has to be differentiable along the open interval of a to b, which means on the whole function, it can't have points or anything that you wouldn't be able to find the slope of. And the function of a has to equal the function of b. If they don't equal, then you use the mean value theorem. But if they do equal, then you use Rolle's theorem. And if all these criteria are ticked, and you have all that, then the derivative of f of c equals 0, and you use this to find the value of c. The point at which the slope at that point is equal to the slope running through these two a to b points. Okay, so example 1. We have a function equal to x to the power of 3 plus 2x to the power of 2 minus 3x plus 5 through the interval of -3 and 1 domain. Okay, and this here will look something like a function. This will be 2, 4, -2, -4. Or we'll have to go 2, 4, 6, 8, and it goes on a bit. And our function will look something like up and then it comes back down. And the points we're after are -3, which is about here, and 1, which is about here. Okay, if we trail that down, that is 1, which is our b value, and if we trail this down, that is -3, which is our a value. Okay, because this is our a and this is our b. And we want the y points, the function of these both, to equal the same thing. Okay, so let's find that out first. Well, criteria we can specify between these 2 points. It's continuous. That should be more rounded, but it's continuous through these 2 points. And you can find the slope at any point on this whole curve. So it passes the first 2 criteria. Now we've got to see if it'll pass the third. So a is -3. If we sub -3 or a into the function, it spits out 5. And b is 1. And when we sub that into the function, we get 5. Which therefore means that fa equals fb. 5 equals 5. Tick. Okay, so we've proven it. We've proven the criteria, or we've shown that the 3 criteria are you can use the Rolle's theorem because the 3 criteria are specified as correct. I'm not very good with English. Okay, so anyway, that means that the derivative of function of c equals 0. So the slope at point c equals 0. Okay, now that's out of the way, that means that these 2 equal, so we can draw a line through them, and that is our secant line which passes through. Okay, and what we're looking for is we're going to be looking for 2 points, because we're going to be looking for points a point or points where the slope at those points are equal to the slope of the line passing through the 2 points. So there'll be one here, and there'll be a point up here, where the slope at both of these points will be equal to the slope going through here. Okay? That's what we'll be looking for. So we'll be looking for one point in between 0 and 1, and another point in between, or around -2. Okay, so let's get started. First, we have to find the function of c before we can derive it. So the function of c is just the same as this, except you replace all the x's with c's. So that'll be c cubed plus 2c squared minus 3c plus 5. Find the derivative of that, and you get 3c squared plus 4c minus 3. And that is, we can use a quadratic formula on that, because that looks like, oh, well, when we set it to 0, so we let the derivative of c equals 0, and then we get 0 equals 3c squared plus 4c minus 3, which looks like 0 equals ax squared plus bx plus c. Okay, and the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac over 2a. Okay, I won't show you how to use the quadratic formula in this video, only because you should know the quadratic formula by now or how to do it. If you don't, I will put a video up in the future on how to do it, but I'm just going to give you the answers that it would spit out. So you would get two values. One value would be with the plus, and one would be using the minus. So the first value of c will be equal to 0.53, and the other value of c you'll get, c2, equals -1.87, which makes sense, because when you look at the graph, I said that one point needs to be between 0 and 1. We have 0.53, and one point should be around -2. We have -1.87. Okay? See? So at this would be C1, and this here would be C2. So at these points, trail them up. Where they line up, the slope at those points will be equal to the slope passing through the two points passing through the interval, which in this case is 0, but those are the 2 points. Okay, now I hope you learned something from this video. That's all. If you're looking to find the y values, you just sub them back into the function and you'll get the y value for that and that y value for that. Anyway, so I'll leave you to it. Thanks for watching and have a good day.